Actually, this learning outcome for only for 3 credit subject. Okay, so this is not relevant to 1 credit and 2 credit. Already we have completed 1 credit syllabus. Okay, so you can see that in LO1 we have to learn DCAC bridge. We have already uh, done that one. Okay, so voltmeter and ammeter we have already done that one. Then we have to learn the single source and function generator. Okay. Okay, so I think we have to discuss this one also little. Okay. So signal source and function generator. Signal source means what? So I think that's also, if you have a general idea, that is enough. Okay. We no need to do any calculations or things. Okay. So actually, you have to practically use these signal sources and function generators. Okay, then you can see the error. Okay, error and how those errors are handled. Okay, so those are the things actually we need to learn. Okay, but operation principle I will explain very briefly. Uh, so it is like this. Okay, so signal voltage generator. Okay, signal generator means actually those are voltage generator. Those are voltage generator. Okay, then what are the normal or natural signals we can generate? What are the natural signal we can get? We can get basically 2 natural signal. What are they? Voltage, if you consider voltage. In a battery, you can get a DC signal like this. Okay, DC signal. Actually, this is not like this. Okay, the battery will be drained. Okay, so this kind of signal is there. Okay, actually, this kind of signal is there, but approximately we can assume this as a DC. Okay, so this DC voltage you can get from a battery. That means using a chemical reaction. You can generate a DC signal using a chemical reaction. DC. Then also you can generate AC signal. How? Using a dynamo. Okay. So you can generate AC signal using a dynamo, and also you can generate this kind of half wave signal also using a dynamo. Okay. So this is related with the magnetic induction. Okay. So this is magnetic induction. Okay. So these are, I think these are the 2 voltages we can get without a problem. Okay, using a battery. Okay. So, and also if you have AC signal, okay, AC signal, okay. So this is generated by a dynamo. Okay. So normally our commercial power is uh, this kind of signal, commercial power. Okay. Then we can get that signal. Then we can send it through a rectifier, good rectifier system. Then you can get a steady value like this DC value. And also if you will get a DC value, maybe using a battery, you can use an inverter. Okay. So inverter can be made of with transistor and diodes. As I can remember, 4 diodes, 2 transistor and 4 diodes, as I can remember, I'm not sure. Rectifier you can use, you can construct using diode bridge and also using a regulator circuits. Okay. And you can generate this one. Okay. So generation of AC signal, sine signal, and DC signal is not a problem. DC signal is not a problem. Okay. Okay. So actually those are some basic things we can use. Okay. But okay, actually this AC signal, these signals are generated through a dynamo. Okay. So this AC signal normally the commercial power signal. Okay. So for electronic circuits, also, for example, in communication. neither. Sorry, you are power, no? Okay. So maybe power also to get so sometime we can't use always. So maybe for some for some control and other things, okay, for communication. For example, in communication, if we need to modulate a signal, okay, we need to have a sinusoidal signal like this. Okay. So this kind of sinusoidal signal we can't generate from a dynamo. That is not practical. Okay. So that means every TV and every cassette should have a dynamo, no? So that is not practical. Okay. So now normally what happened? Normally what happened? So normally we have AC power, AC signal, commercial power, that is 230 voltage. Okay. Then normally that 230 voltage is step down maybe to 12 volt. Then it is rectified. Then you can get a 12 volt DC signal like this. Okay. So this signal is feed into an electronic system normal. Okay. So 12 volt signal is there. 12 volt or some DC signal is there in electronic circuits. Okay? In electronic circuits. Right? Then this electronic circuits also need to generate sometime sine wave. Sometime maybe RAM signal. Okay. So sometime maybe uh, triangular signal like this. Triangular signal like this. Okay. Or sawtooth signal. Okay. Or maybe square signal like this. Okay. Or maybe a clock pulse like this. Okay. So there are many type of signals sometimes we need inside electronic circuits to operate and control and any other works. Okay. So to generate this kind of signal, this kind of special signal, okay, using this DC supply, using a DC supply or using a DC source, okay. So for that one, we need signal generators and function generators. Signal generator and function generator. Okay. For example, if you have a DC current, DC signal, okay, so very easily you can construct a on-off signal, automatic signal. Maybe in grade 7 you have designed this. Okay, using a transistor and a capacitor. Okay, okay, using a transistor, one transistor and one capacitor, and maybe a resistor. Automatic circuit එක LED automatic එක LED එක on වෙනවා off වෙනවා LED එක on වෙනවා off වෙනවා on වෙනවා off වෙනවා. So you are generating this kind of function, this kind of signal. So that simple circuit is a function generator. That simple circuit is a function generator. Okay. So if I can't remember that circuit now. Okay. So maybe if I type LED blink, LED blinking circuit diagram. Okay. This one I think this one. Then we have maybe two LEDs on and off. We do like that. Okay. Is that circuits? This is a multi-vibrator. Actually, this is not we are using. Okay. This is a multi-vibrator. I can't find that one. Okay. Actually, one resistor, one capacitor, and diode. Okay. Using a transistor. Okay. One transistor and I think this one, maybe. This one. World simple LED flasher. Maybe you can see it, okay? So, yeah, is the circuit diagram. Maybe this one, yeah. Yeah, this one, no? Yeah, this one, I think. Okay, so this is the simple LED flasher. Okay, actually here we have a on off signal. Okay, so very simple. Okay, uh, so this one is charge and discharging happen. Then this maybe this is not correct. I'm not sure. Okay, just check. Okay, if you need. Okay, so anyway, this is a simple signal generator. That is what I want to know. That is what that idea I want to give you. Okay. Then also maybe you can use you can maybe some circuits maybe we can get this kind of one that is also a blinking circuits that is two side blinking one, two LED blinking one. So that circuits will generate this kind of signal. So that is also a function generator or signal generator. Okay, so then we can smooth this value, smooth this one. Using smoothing uh, we can modify this system to generate sinusoidal signal. Okay, so there are many sinusoidal signal generators are there, oscillators actually. There are many type of oscillators are there. Okay, the crystal oscillator like this. Okay, so using oscillator also we can generate this kind of signal. Okay, so those are the voltage generator, function generator. So that is the normal working principle. Okay, so using a simple circuit we can construct it. Okay, using a simple circuit we can construct it. Actually, uh, this one. Okay, that is a simple inverter. That is also function generator. Inverter. I told you this one. Okay, this is the basic inverter. Okay, so I told you. Okay, so there should be 4 transistor and 4 diodes. Okay, there should be 4 transistor and 4 diodes. So what happened is here. Okay, so when so you can see that the battery is connected like this. Okay, so if we switch this transistor, and this transistor, the current is flowing like this. Okay, current is flowing like this. Okay, if we switch this one, so that means here path is there, here path is there. Okay, so current is flowing in this path. Okay, so we have a current flowing in this path. Okay, and if we switch this one and this one, what happened? Okay, so current will flow, current will come here. Okay, so now this is not on. Okay, so current will not go through this one, then current will go through this one. Okay, this one and come into here and this one. Okay, so what happened? One time when you switch this one and switch this one, the current is going like this. Okay, in this direction. Okay, current is going in this direction. That is a constant current. Okay, so voltage is in this direction. Then once the this one and this one switch, okay, the current is going through this direction. Okay, this direction and this direction. So what type of signal it is generating? Okay, so if you have a transistor like this, okay, and if you connect a diode like this, okay, if you have 4 setup like this. Hello, මේ මගේ lecture එක. Hello, මේ මගේ lecture එක. Okay, so So, so there is a resistor like this, okay? So one time the current is going through this, okay? So that current is going through this. Again, the current is going other direction, okay? So current is going in this direction. Okay? So it generated this kind of one. So this is a signal generator, function generator. Okay. So so there are very simple methods we can use to construct a signal generator. Okay. So I think that idea may be enough. Okay. So what you need to do is you need to use these signal generators. So function generator means that is the basic one. Okay. Okay. So there are many function generators in Paragraph. So you can see that this is a function generator. Okay. So this is a function generator. Maybe you have used this one, okay? So we can get several type of signal. Uh, Here sine signal, sawtooth signal, uh, triangular signal, square signal, okay? So we can get different type of signals, okay? So these are the outputs, okay? These are the outputs, okay? So these are the function generator actually, okay? So So that different function generator will create different type of errors. Okay, so those are also need to be practically experienced. Okay, so I think that is enough for this one. Okay, signal source and function generator. Okay, so I think we have already discussed oscilloscope and related measurement last week. Okay, so oscilloscope we can use to measure what is called electronics, that means what is called time domain signals, okay? And electronics counters we have discussed now, okay? And spectrum and net, we haven't talked about network analyzer. I think uh, maybe network analyzer, actually we are using network analyzer for measure microwave related parameter. Actual reflections, okay? Those are called S parameters, okay? I don't know, those S parameters are related with power. Do you have any idea? So actually this reflection happen at high speed. Okay, normally in microwave, RF and microwave frequencies, sometime reflection happen, okay? So when you are input a signal, okay, one section to another section, if those section impedance are not matching, some part of a signal will be reflected. That is we called as reflection, okay? So based on this reflection, there are some parameters we can define. Those are called S parameters, scattering parameters, okay? So I don't know that is related with power, okay? Anyway, spectrum analyzer we have discussed, okay? And logic analyzer we haven't discussed. Actually, logic analyzer is also oscilloscope. Okay, it is just like oscilloscope. Okay, but using a logic analyzer, sometime we can see the type of signal also. Okay, so there are many type of logic signals. No, for example, there are some communication signals. Okay, modulated signals are there. Okay, so some frames are there, okay? So that kind of frames and signals we can detect from logic analyzer. That is also time domain one, okay? Time domain one, okay? We have logic analyzers in campus, okay? So now there are very cheap logic analyzers are there. Okay. So we have one or two here. Okay. So I think that may be enough. Okay. Oscilloscope, I think basically you need to know oscilloscope measurement and spectrum analyzer measurement. Okay. The logic analyzer um, maybe important. Okay, I will anyway. I have a video. I will share it with you using a logic analyzer. Okay, then you can understand what is the importance of logic analyzer. I will share it with you. Maybe you can check. Okay. So I hope that may be enough. Okay, so here we need to learn the operation principle of oscilloscope. Okay, so basically there are two types of oscilloscope. Okay, the cathode ray oscilloscope, and there are many types of oscilloscope. Okay, in our labs we have basically two types of oscilloscope: cathode ray oscilloscope CRO and digital signal oscilloscope DSO. Okay, and actually another sampling oscilloscope is also with us, that is optical oscilloscope actually. So that is supporting very high frequency. Okay, very expensive instrument. Okay, but basically we are using CRO and DSO for our lab measurement. Okay. Uh, so I think maybe we can learn the operation principle of that one very briefly. Okay. Example, if you consider cathode ray oscilloscope, CRO, working principle. Okay. Uh, okay, so it is somewhat uh, complex. Okay, it is somewhat complex. Uh, Maybe we can use this one. Okay, so you can see that. Um, so normally this is a cathode ray. Okay, this is a cathode ray. I think uh, in cathode ray. Okay, so actually I can't understand how this cathode ray CRO is working. Okay, the TV display working. I I haven't I can't understand totally. Actually, microphone operation is also I can't imagine. The microphone. Okay, so the operation I know. Okay, operation we have we are learning that operation in maybe in grade 7 science. Okay, 7 වසරේ විද්‍යාවට තියෙනවා මේ microphone එක ගැන. කොහොමද microphone එක වැඩ කරන්නේ කියලා. When we are talking, there is a small what is called a small plate is there, conductor plate. Okay, so that is vibrating according to our voice. Then it is vibrating in a magnetic field. So it is creating a current. Okay. So that current is directly related with our voice. Okay. So, so our voice is converted to current. Then when it feed to a speaker will do the other side. When we feed it to the speaker, so again there is a plate in a magnetic field. So when we are sending a current, okay. So when we are sending a current to a conductor in a magnetic field, it has a force. Okay, then it is also vibrating. Then our voice coming out. Still, I can't imagine how it happened. The same voice it is coming, no? That is just using an iron plate, but that iron plate produce our sound. That is a magic for me actually. Okay, I don't know what about you. Okay, but that is it is like a magic for me actually. Okay. Maybe you, it is not maybe for you, okay, but for me it is just like a magic. Okay. Okay, actually cathode ray oscilloscope is same. Okay, the television is very, actually that is also magic for me, television and displays. Okay, and also the camera. Okay, those are the basic instruments. Okay, camera, speaker, cathode ray oscilloscope. Okay, still I couldn't understand how these are working. Okay, so I just tell you the principle. Okay, what is that one? What happened that I will take it. Okay. Maybe this one is more uh, simple. Okay. So in cathode, so uh, here we have the cathode ray. Okay, and here we have electron gun. Okay. So uh, when we are giving a voltage to this plate, okay, so these are actually just like electrodes, okay. So these are vertical deflection plate, okay. So due to this voltage, this electron guns move, okay, move, and these are horizontal deflection plate. So it is horizontally deflect, move, okay. So this movement, okay, by moving, okay, this is just like a pen, electron gun, okay. So it shoot the electron to the to a screen, then these electrons will draw a picture here. Okay. So drawing, it drawing the picture by moving this electron gun. Okay. So that is moving according to the given signal. Okay. So given signal, it generate uh, it draw a picture. It draw a picture of the signal. Okay. So that is the basic operation. So that is very complex for me, okay, to identify. Okay. So here the amplifier is there. Okay. So that means we need to amplify it up to some level. Okay. Okay. Uh, then trigger circuit is also there. Trigger circuit means actually we need to give a trigger. Okay. So we need to give a trigger to identify the position of the signal. Okay. The signal cross point. Okay. To identify the signal cross point, we need to use a trigger circuit, trigger signal. Okay. So I think that may be enough. Okay. So we can't talk many more. Actually, I also doesn't have idea. Okay. So maybe if you need, you can read this and try to understand this totally. Okay. Okay. So that is the analog cathode ray oscilloscope. That is analog actually. Okay. But digital one is somewhat simple. Okay. So I told you that there are basically two type of oscilloscope. Okay. Oscilloscope. Okay. One is cathode ray oscilloscope and other is digital storage oscilloscope. There are many types. Okay. Actually, that is related to digital storage oscilloscope. Sampling oscilloscope, multi-signal oscilloscope, MSO. This is also called as wideband oscilloscope. Okay, so there are many types of. Okay, we have this one also. Okay, so DSO is very important, very easy. Actually, DSO, the main component is again analog to digital converter. Okay, so we have analog to digital converter, ADC. Okay, then we have processor. We have a processor. කොයි හරියද මේ කත්තුනේ?
So, oscilloscope types.
මෙතනදී නේ?
Oh,
So I'm explaining this, no? We have two oscilloscopes, CRO and DSO, and there are other types, okay?
yes.
And uh, And actually, the operation principle of the DSO is very simple. We can construct a DSO very easily. Okay. So what we need to have analog to digital converter. We can get it from a shop. Then we have a processor. You can use Arduino processor. Okay, not processor. Arduino. Okay. Arduino ESP32, Raspberry Pi, anything you can get. Okay. Then we should have a LCD display. LCD display. Then we should have a storage device. Storage. That is the only thing. Here we need to have a DAC DAC. Okay, DAC also. Okay. Then what it doing? If you are giving analog signal, okay, so it sample, quantize, and encode. Then it generates some sample value. Those samples value can be stored here in the storage. Okay, like this. Okay, so that is why it is called storage oscilloscope. We can store this sample. Okay, then whenever we need it, we can get these samples to one port. Then we can send this sample to a digital to analog converter. Okay, then we can construct this one again. This one. Okay, then we can send this to a display. We can display. Okay. So you can use Arduino to construct a digital storage oscilloscope very easily. Okay, actually analog to digital converter also no need because Arduino has its own ADC. You have to use only a DAC. Okay, so you can plot this one. Okay, actually without a DAC also there are some methods we can plot. For example, we can get this sample to the computer. Okay, to the computer. Then using Excel we can Excel tool, that is spreadsheet tool, we can plot this waveform. Okay, so that is very easy. That is the principle of DSO, digital storage oscilloscope. ADC there, processor there, then storage is there, then analog signal is converted to a digital bits. Okay, then store it in storage. Then once we need it, we can get it and convert using a DAC and we can solve. Okay, so that is the basic digital to uh, uh, DSO operation. Okay, so I think that is enough. Okay, so oscilloscope working principle is like that: CRO and DSO. Okay, I'm sorry, I can't wait much time. I can't spend much time to explain this. Okay, because we are running out of time. Actually, that is the problem. Okay, okay. Now, if you consider the spectrum analyzer, the spectrum analyzer is also very easily construct. Okay, so spectrum analyzer means if we are given a signal, okay, if we are given a signal, so maybe you can remember what is the output of the spectrum analyzer. So if we have a signal, okay, so let's say that we have a signal from 0 to 50 hertz or something. Okay, so we have a signal. Okay, that means we have several sinusoidal signal combined. Several sinusoidal signal combined. Okay, so this sinusoidal signal component you can find using the Fourier series, Fourier analysis. Okay, Fourier series representation of Fourier transform. You can find this frequency component. Okay, then spectrum analyzer will plot the amplitude or power of this each sinusoidal component like this with respect to the frequency, Okay. So what is this normally has? It has the frequency and corresponding power or amplitude. Okay. So this can be, so spectrum analyzer can be construct using two methods. Okay. One method is you can get a time domain signal. Then using Fourier analyze, actually you can use fast Fourier transform. There are some algorithms we are using FFT. Okay, So you can apply that kind of algorithm. So there are two types of fast Fourier transform method, decimation method, and decimation in time and decimation in frequency method. You can get any type of method, okay, to convert this time domain signal into frequency domain, okay. Then you have calculated the frequency domain signal, then you can show it, okay. So that is one type, okay. And other type is most probably optical spectrum analyzers are based on this type, okay. Most probably optical spectrum analyzer, okay. So what it do is, once we give a signal, let's say that 0 to 5 gigahertz or something, this signal is sent through a band pass filter. Band pass filter means it pass only a intended band. Okay. So this will be a tunable band pass filter. Okay, tunable band. This band pass filter can be tuned by a voltage or something, voltage or giving a voltage, or maybe a other method also you can use. Okay. So the voltage is very easy one. Okay. So band pass filter you can construct using capacitor and inductor. Okay. Maybe you know that varactor diodes are there. Varactor diodes and pin diodes are there. So when you are giving the, when we change the input of the varactor diodes and pin diode, the capacitance and resistance will be changed. Okay. So this band pass filter, the based on capacitance and inductance. So once when we are changing this capacitance, we can change this band pass filter properties. Band, actually the pass band we can change. Okay. So you can tune it. Okay. Then you can get a band. Then that band can be sent to a power meter. Power meter also very easily you can construct.